Alright, we're back. Next. I don't allow you to make displacements. Oh, okay. We have to click the number, though. I thought we were clicking through. Oh, that's a lot more levels. Oh, hell. That's a lot more levels. Let's go. I I did start from the end of the last video. I've basically just jumped straight into this video. So I haven't had time to actually build all of the stuff below the YouTube stuff yet. So I'm still thinking about it. But I did just take a quick break and go watch the Numberphile video about the Zeno's paradox and the Achilles and the turtle, and basically how everything tends to infinity by halving it and halving it and halving it. And Brady's gonna be able to explain that in a way. He's going to be able to teach you that in a way much better than I ever could. So I'm linking that specific video below, and you can find the channel through there, obviously. So introduction to the concept of velocity. Now we are driving. Now we're going to be driving. Okay. I don't know what the 10 and the 20 mean. Updating space tow truck. But now we are going to be driving. Antimatter impulse module installed. I did do a bit of this also in the demo. Ready to apply a velocity to the car. There we go. So this is where it's going to get tricky. E equals mc squared. Use the antimatter impulsions to give velocity to your vehicle. With our exclusive platforms, you'll be able to glide without losing speed, but don't slide into the walls. Okay. Technical note, our control panel. Oh, we already read this one. Our control panel linked to our antimatter pulse generator allows to control the velocity of an object. Okay, when it's constant, the magnitude of its velocity is equal to the magnitude of its displacement over time, of the time interval of this displacement. Okay, so velocity equals the displacement norm over the time. So, time in seconds, 1 second, 20 meters per second, 20, of course, right? It's per second, so, obviously. Pretty simple stuff. Just multiplying this by this, essentially. Because, yeah. You can always take these triangles. We used to have them as triangles in high school, and it was like whichever part of the triangle you hide is kind of what you're trying to calculate. So if you want this, which is, your velocity, which is basically your kind of your displacement, your kind of distance over your time. And it's, you would just hide velocity, and it would be like in a triangle. In fact, let me draw it out. Let's say distance over time, let's just say. And it's in a triangle that looks like this. And if you're trying to figure one out, you hide one. So currently we're trying to figure out velocity. So it'll be d over t. And if you're trying to do distance, then it's v times t. If you're trying to work out t time, then it's distance over velocity. And that's kind of how we did a lot of those equations. Those equations that look like this, you can put them in the triangle, so you can just see easily how to figure them out. It's basically just a rearranging of of any equation, basically, but it's just a nice little way to see it. So, we have 2 seconds, so we need to do at least 10 a second along the y-axis, right? So let's go, because we need to get to the battery. 1, 2, perfect, just on time. I knocked my microphone a lot there. Hopefully I didn't cause too many ears to shatter and your eardrums to shatter. That one's done. Let's read what is this? Here is Eratosthenes? I don't know who that is. He was the first to measure the circumference and diameter of the Earth. I thought it was done with the 2 cylinders. It was at the time the distances of objects in the sky were always given in relation to the diameter of the Earth, the Earth-Moon distance, or the Earth-Sun distance. With the measurement of the diameter of the Earth, we could finally estimate how far celestial objects really were. His technique for measuring the circumference of the Earth was very ingenious. He used the geometry and the shadow of the sun cast on 2 objects located in 2 different cities. So this was the guy. This was the one who did it. And basically, like, imagine like 2 sundials kind of thing. So that you could see the shadows cast around different places. Since these 2 cities were not the same latitude, the shadows cast on objects in 2 cities were not the same. The distance between these 2 cities was known, which allowed him to complete his equation. He designed an efficient method to find out if a number is a prime number, a number that can only be divided by itself or by 1. Which, by the way, means that number 1 is not a prime number, because it can only be divided by itself, which is 1, but you need to be able to divide by itself, and 1, basically. Okay, Let's go. Here is the Sea of Knowledge. It did not receive its name until 1964. It is located in the Ocean of Storms. The majority of the moon's seas are on the visible side of the moon. That is, the side which is always towards the Earth. On Earth, we always see the same face of the moon because the time of rotation of the moon on itself is equal to the time of revolution of the moon around the Earth. Yes, we know that. That's why the dark side of the moon is so creepy. 3.2, looks like we got to go this way and then go back, which is going to be awkward. How do we do this? Okay, so we've got 6 seconds. So we need to go, if we do it per second, we can go minus, no, we go minus. But then we've got to do this. Ooh, this is a little tricky. Have you noticed the batteries? Have you noticed you can click on the batteries to their positions? Oh, interesting. Okay. Because then we need to switch back. But this way, once we're here, we need to go 5, 10, 20. Right? In 3 seconds. So if we go 10. So if we go 5, 10, right? So if we go 3 seconds, 1, 2, 3, and then we go 1, 2, 3, that should be okay. So we'll go here. No, 5 seconds. So 5 meters a second. So we go 5, 10, 15 in 3 seconds. Then we switch and we're going the opposite after 3 seconds to go 10, 20, 30 from 10 times 3. The 3 seconds we have left. Let's see. Is that going to work? Boom! And we go back the other way twice as fast. Heck yeah, look at that. Very cool. I like how the things come off screen and hit the car to make them go the opposite way, like give them the force. Alright. Here is Apollonius of Perga. From the work of Euclid and Archimedes, he developed a branch of geometry that will be very important for understanding the movement of planets and the trajectory of projectiles, conics. His definitions of ellipses, parabolas, and hyperbolas. I don't know what hyperbola is. I know what parabola is, but there are still the ones we use today. What is a hyperbola? I need to write that down somewhere. I'm gonna check that out. Hyperbola. Why do I not know what that is? Okay, anyway. Hyperbola. This game is delight. Is a total delight to me. Okay. 3, nothing new. I think now we're actually gonna have to travel a different. Okay, yeah. This is a little weird. This is a little weird because we need to kind of go. Oh, do we need to just survive? We need to just survive. So why don't we just wait? Oh, for 3 seconds. So we need 2 seconds. Oh, no. I was going to say we don't do anything until it gets to 3 seconds. And then we go +5. But then we just die, right? After 4 seconds. What we do then instead, I guess. No. Because we only can do it twice. We can only move twice. What I'm thinking is we move down and then back up twice. Right? So if we move down. What am I doing? Down. So we go down here in 1 second. And then after 1 second we go plus. That'll be 2 seconds, 3 seconds, but we still don't survive. Let me just try it anyway. I want to see what happens if we hit the wall. We do die. Okay. Okay. Just to be sure. Just to be sure. Now we've got a little puzzle on this hand. What is this, by the way? Why was that music off by default? I want the elevator music. Okay. What we could do is if we go. Huh. I'm thinking now. If we do go minus, we go down here at an angle for 1 second. And then... this is... If we go down here. Along the hypotenuse, and then let's check this out. I'm curious. And then plus, let's see. Still, we only have 3 seconds. We only have 3 seconds. I just want to. I wanted to see if it's going to actually allow us to go diagonal. It does. We are not going to take a hint. We are not going to take a hint. But what I want to do is kind of be able to drive around the whole thing, right? So 1, 2, 3, 4, 5. But that would take more velocities, more velocity kind of changes. Maybe we just do, yeah, 5 seconds, 3 seconds. We go here. Can we survive? Let me just try this. We're gonna not move until the last second, and then we get hit. Do we survive? No. Okay, so it is death after that. I was trying to just cheat the game out of it. We can't change. Oh wait. Oh no. That's all. Yeah, yeah. It's just the scrolling thing allows us to go down further. Ooh, this is tricky. This is real tricky. Because if you do go down here, and then after 1 second, we start moving up here, so it's 1, 2, 3, but then we can't move again. We can't go back here. We only have 1 movement. That's what's confusing me. We've only got 1 change. We've got to survive for 2 seconds somehow, which means we kind of need to be down here. We can't go any slower than this. That's not what I did. Okay. Oh, I can move around as well. I can look around. This has got me stumped. I feel like I need an extra movement. If I move... One, 2, 3. I just can't go back. Because we can't change our initial place. We have to be here. And the slowest we can go is 5 meters a second, which in any direction kills us in 2 seconds. So after 1 second we change it, in which case we only have 2 seconds to go back. I'm very confused by this one. Honestly, I'm going to skip this one. I'm confused by it. It seems... I feel like I can't beat that one right now. I feel weird. Introduction to floating batteries. That one's tricked me. That one is a... Don't have to think about that one. We'll go back. We'll be doing this world in this video. The battery will remain suspended in the air, but only for the time indicated. So in 4 seconds, it's going to drop. We have 6 seconds. We could just wait here for 4 seconds. And then bolt it. And then we could, you know, well, we could just do this. 20. 5 seconds. Because it'll take a second to drop also, is what I'm assuming. What did I do? What did I do? I'm pressing X. I'm going on the X-axis instead of the Y. Silly boy. But this seems like, seems reasonable. We get there just in 1 second. Oh. Yeah, simple enough. Okay. That one was so much easier than the other one. This one was after it? I feel like this 3.3 is almost missing something. Hero of Alexandria. Here is Hero of Alexandria. Prolific inventor. He would have invented the Euclidean, the first steam engine. It was only used only for entertainment. He didn't see his inventions as anything useful. Oh my god. He would have invented an odometer. That is to say, a device to calculate the distance traveled. Isn't that the when you like measuring something on the ground and you basically have like you know, a circular object. You're like a wheel, basically. And you would mark it, and every time it goes round once, that's, you know, a meter, because, you know, the diameter is a meter. Is that what he did? He would have also invented a windmill, a fountain, automatic doors, and a vending machine in which you have to insert change to have water. Oh my god. What a guy. On February 5th, 1971, Apollo 14 was the third spacecraft to land on the moon with a crew on board. We're skipping the first one. The purpose of the mission was to explore the Fra Mauro region and install several data collecting instruments. This region of the moon is made of debris from the impact of the asteroid that created the Sea of Rain. Those debris are partially composed of layers under the moon's surface and could potentially uncover parts of its geological history. On February 6, 1971, astronaut Alan Shepard became the first person to play golf on the moon. More than 40 kilograms of lunar rocks and dust were brought back to Earth on this mission. Wow. Okay. 3.5, where are you? There we are. Difficulty 2. We're going back down a little bit again now. We're going up at an angle. I think we've just got to do one thing at an angle. Not so bad. So, we can just go positive on the Y, negative on the X. And we have 2 seconds. So, that's 2020. So, let's do 2020. We've got 2 seconds to do it. Whee! Bop! Bop! Lovely, lovely. Very simple. At 3.3 still got me. Still got me. Still tricked me. I'm trying to think. There's got to be something else we can edit. Claudius Ptolemy. He's the author of the Almagest, which means the best. A collection of all the astronomical knowledge of the time. In it, he perfects a sophisticated model for explaining the movement of stars and planets in the sky. In this model, the Earth is at the center of the universe. It's the geocentric model. His geocentric model corresponded within 5% to astronomical observations. He was therefore the model that came closest to what we observed in the sky. His model would mark the history of science by remaining the reference model to explain the movement of celestial objects in the sky for nearly 1400 years, even if we know today that it is false. Crazy, but you've got to base off something, right? You've got to base off of something. It's good to have a concept there. And then you can correct it over time. Okay, oh, this is a tricky one. So what we want to do is actually kind of go into the middle of this square. So, and we have 2 seconds again. So we want to be traveling 25 at least. So we want to go here down to here. So we want to be to -10. We want to go to -10. -10 on the y-axis, and we want to go to -30 here. So actually we're going to go -5 and -15 because we're going to do it in 2 seconds. Yeah, there you go. Work backwards. Gotta work backwards. We're still on the easy ones, man. I can't imagine what a level 10 is going to be like. We've got some level 5s and 6s up here that I'm worried about. John Philoponus. After 8 centuries of waiting, he is one of the first to question Aristotle's physics by relying on what he observes in nature. According to his observations, the mass of an object has little influence on its speed, on the speed of its fall. There you go. According to him, Aristotle was therefore wrong. An object twice as heavy does not fall twice as fast. Correct. While Aristotle believed that air is like a motor that allows a projectile to move, he suggested that instead air is like a brake on the movement. There you go. The creator does not exist on the moon, but this scientist is important, and he added it anyway. He keeps doing that. Keeps getting us with that. 3.7. Okay. This chair, I have been on this chair. I've made so many videos today. My butt is broken. And did you know that in space there is no sound? Indeed, the sound wave is a mechanical wave which needs a medium to propagate, like air. And in the vacuum of space there is no air, so... So, we have 6 seconds. So why don't, if this is 15, and we move 5 a time, right? -5, so we go 1, 2, 3. We actually want to be at 1, 2, 3. We want to be at 15. And then we have 6 seconds to move all the way across. So 1, 2, 3, 4, 5, 6. Lovely. Very nice. Very nice. I like this game. It's just so... I don't need to... I'm not dashing around and slashing enemies, and it's just take my time, think about the answer. We're still in the very easy areas, but we're about to get trickier. I'm excited. Al-Khwarizmi. He developed a mathematical process to solve without trial and error linear and quadratic equations. It is the birth of algebra. The word algebra comes from an abbreviated form of the title of one of his works. The word algorithm is inspired by its name. An algorithm is a procedure for arriving at an answer. Algorithms are widely used in mathematics and are the foundation of computer science. He popularized the use of the Indian Arabic numerals that we use today. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 again. So this is really funny because I've always been taught, I always knew that 0 was created in India. 0, the idea of the number 0 was from India. And when I came to Mexico, I can't remember what subculture of Mexican it was. Is it the Mayans or invented 0 as a concept? And so they believe they invented 0. And Indians believe they invented 0. It's like a big part of their culture. And when I was here the first time, we had a couple of Indians in the company working with us, and it was like India, really the Revolution Day, basically the day that, that the Great Britain released India back to the Indians, basically. So not a great day for my history, but a great day for them. And so they were celebrating that. It's like the Independence Day of India. And they played a video in the office, right? Like it was like a celebration of India and the stuff that they've done. And it had like, invented the number 0 and the concept of 0, of nothing. And I knew it was going to cause something. I thought it was really funny. I just looked around the room and just saw a bunch of people like, what? Like, what? No, that's our thing. It's really funny. So Indians and Mexican both thinks that's from their culture. I don't actually know the truth of where it comes from, or if it was invented independently in those two places at different times, but it's just a very funny thing. 3.8, let's go. Let's go, but yeah, I just thought that was really funny. Okay, you are moving here and back again? Okay. Can I not just move up and then across? Can I not just move... We have 6 seconds. Can I go 1, 2, 3, 4, 5, 6? You know what I mean? So across this one at 10 after 2 seconds. And then this one's up 5 on the y-axis. Let's just try this out. It should be 1, 2, 3, 4, 5, 6. I don't know why that drone's at all a bother to us. Okay. Okay. Sure, that was a weird one. Al-Biruni. Here's Al-Biruni. While Aristotle believed that a moving object could constantly experience a force, he understands that force rather seems to 1. Change the direction of an object. 2. Change the magnitude of its speed. It measures the radius of the Earth, 6,339.9 kilometers. This value is only 16.8 kilometers below the modern value. Wow. 3.9. We're going up to level 4, baby. I'm scared. We need an initial position and 2 changes. If we have an initial position down here, we have, and at 3 seconds, we have to have it. We can go 1, 2, 3, 4. So if we go here, we go 1, 2, 3, 4, 5, 6. Sure. So why don't we go 5? Oh, we can't do the y-axis. Okay. Oh, we can only go minus 15. So we actually want to go up and then down. Or down then up. But it doesn't really matter too much. So, we want to get here within 3 seconds and then here within 3 seconds. To do that, we need 1, 2, 3, 4. Ooh. So 2, 4. 2, 4. But we have 6 seconds and we will die if we go too fast. So this is a little strange. At 3 seconds, that's not good for us. That's not good for us. Instead, only change here to minus. We can go 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. And then 1, 2. Oh, and then how do we get down here? Ooh, this is a hard one. 1. Let's first get to this one by going 1, 2, and we'll go up to this top corner. So we're gonna start over here. Then we're gonna move. We want to move plus 10 on the X and plus 5 on the Y. So we're gonna move 1 second, 2 second, 3 second. We're gonna be here. Then at 3 seconds, we want to move down to like here. This is awkward. So that'd be going to 20, right? To minus 20 from plus 15. Which means it would go like this, and it would go like this. That wouldn't make sense. Go down here, down here. No. Halfway through. Maybe we go do this one first, and then head back up. No, because they're equal anyway. It doesn't make a difference. Doesn't make a difference. 1. This will bring us here to this top corner in 3 seconds. And then we need to get down to here in another 3 seconds. So we can go 1, 2, 3. But we'll miss this, right? Because we're not going directly through it. So we actually need to get here. Which we can do here to here is the problem. Here to here. In 3 seconds. Yeah. Okay, so we would need to go from plus 15 to minus 10 in 3 seconds. That's 25. So we'd want to do it. It'd have to be at least 10. In fact, minus, because we're going down. It'd have to be at least minus 10. And we're going minus 10 on the x-axis. Minus 5. This is not going to work, but I just want to see what's happening. Yeah. Yeah. That was my initial concept. That was my initial concept. But we can't make it to here like that. So, what if instead we start minus 10 and then it's I don't think we can we do to here? No. Minus 5 would make more sense. And then in 2 seconds get here. 1, 2, 3 seconds I'd be here. That makes more sense, I think. 3 seconds be there. So we want to be plus 5, plus 5. We got 1, 2, 3. And then from here to here, so we're... Oh no, still. Still, that's a weird one though. Still, that's a weird one. We move down here, yeah. And even if we move at less of an angle, or more of an angle, I should say, along. Hey, oh no 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 no. This would just move us down this way instead. So I do feel like minus 10 is the way to go, but this is even more awkward. I don't know how to do this to here. This to minus 10? I don't think we can do that. We can always just start on 0 as well, can't we? Yeah. And that'd be 1... No. This is a good one. I like this a lot. This game's a weird one to record because I'm thinking a lot. I'm trying to think a lot, and talking is a little bit awkward. But if I start at minus 15 and go towards one of these, and go, you know, 1, 2. That's 2 seconds. And then I can just go 1, 2, 3, 4. Oh, wait, what am I doing? I can just go 1, 2, 3, 4. Why am I thinking about this? Why is this is not a hard one? 1, 2. What am I doing? Excuse me, what am I doing? I want to go here to here in 2 seconds, which means plus 10 minus 5. And then I just want to go plus y. 5. What am I doing? Why am I making this difficult? I did it incorrectly. Oh, it's at 3 seconds. That's why it has to be 3 seconds. That's why it has to be at 3 seconds. It has to be at 3 seconds. So I can't go 1, 2. That's why. The 3 seconds law is killing me. In that case, go back to 10. We go 1, 2, 3. 1, 2, 3, 4, 5. Yeah. Oh, no, that'd be 1, 2, 3. Yeah, okay. So from 10, we go positive, positive. 5 each. So we go 1, 2, 3 seconds, and that's the 3 seconds. We just go straight down on the y-axis for 5. Oh, no, for 10, and then go 1, 2, 3. Okay, so 3 seconds to get up above, and then 3 seconds going straight down in a line to get both the batteries. That was a lot easier than I made it out to be. I tilted myself. I was trying to think about way more complex ways to do that when it was a very simple position yourself and just, boom, move down into it. Okay, let's go. This game I'm really loving. This is fun. This is gonna get crazy hard. I'm very, very excited. Ooh, interesting. Interesting. 6 seconds, and I can change my initial position as well. And I can change my velocity twice. What time does they start moving? They start moving at 3 seconds. I was thinking if I move here and then move up at this angle, can I beat them? So if I'm here, and then I have to get here, I can't do that really, can I? I've got to move. So I displace here, and then move 1, 2, 3. Oh, I can change the second at which we displace as well, at which we change. I can move here and then go 1, 2, 3 seconds. Or 4 seconds. No, 4 seconds we're dead at that position. 3 seconds, and then it'd have to start going down, but it can't do that. It'd have to go down here. So we can displace here. And then go 1, 2, 3 seconds. We're safe. 3. And then I think we still crash at this point. Or I feel like we've got to move through them as they move, right? I really want to do that though, even if that's not the way to solve it. I want to move through them. Okay. The thing is, we can always just displace to this battery instantly and then just start moving like up here and then move down maybe. 1, 2, 3, 4, 5, 6. It's probably the way to do it. Let's move 15, minus 15, 15 across, minus 15 down. And then we're going to go from there. We are going positive on the negative on the x-axis 10 and positive on the y-axis 5. So we go 1 second, 2 second, 3. No, wait. 1, 2, 3 actually over here. That's bad. I thought we were... Yeah, no, I thought we were in position. We're not in position there. If I go instead 1, 2, 3, 4, 5, 6. So let's just do that and that. And when I hit here at 3 seconds, we want to be going minus minus. So I'll go here and then 1, 2, 3, 1, 2, 3. Sure. That was a simple one. I really wanted to kind of sneak through them though. I wanted to like try and... I'm thinking about what would be the cool thing to do instead of what we could just do to win. Impressive, you have completed 20 craters. You've more than 20% of the craters you need to be able to leave the moon. Excellent. Averroes, he made the link between the magnitude of a force and the rate of change it causes to the velocity of an object. This is what we now call acceleration. He defines force as something that changes the movement of an object. In other words, force changes either direction of an object's velocity, or the magnitude of the velocity. Got hiccups again. He also proposes that objects have certain resistance to changes in movement. This is the principle of inertia. So important in mechanics. He even made the distinction between inertia, air resistance, and the effect of gravity. Okay. The portrait of Averroes appears in the Vatican on a fresco by the painter Raphael. Really? This proves the influence he had in Europe. Wow. Very cool. 3.11. Getting to the real tough stuff now. Once again, we have 3 changes of velocity this time and an initial position, and we have to survive for 6 seconds. So let's say we go here, and then we go 1, 2, 3, 4, 5, 6. This seems fine to me. Let's do it. Let's go minus 20. Minus 20, 20. And we go along the x-axis at 1, 2, 3. So 10 second. And then we're going to end here after 3 seconds. And we go 4, 5. So then we're going to have to change to go still 5 positive on the x, but negative 5 on the y. So we go 1, 1. That's 2 seconds. So we're going to do this at 3. And we're going to... Oh, this is at 5 seconds anyway. So this is going to do 4. And then 5 seconds. So that's actually not going to work right now. This 5 seconds is an issue. It's 5... Oh, no, wait. 1, 2, 3, 4, 5. Oh, it's going to be fine. And then we just go minus y. And we shoot down there. Let's go. So we go 1, we go 2 seconds, we go 3 seconds, change, 4 seconds, 5 seconds, change, 1 second, done. Cool. Solid. You've just got to kind of work backwards. It's like one of those mazes. You got to find out which pieces do we have to get first. What are the limitations we have? Leonardo Fibonacci. While Europe still used Roman numerals, you know, I, V, etc., he introduced Indian Arabic numbers. 0 to 9, which made it possible to perform complex calculations much more efficiently. He introduced algebra to Europe. He introduced the concept of the number 0 to Europe. He reveals the sequence of numbers that bears his name, the Fibonacci sequence. In this sequence, a number is equal to the sum of the 2 preceding it. 1, 2, 3, 8, 5, 8, 13. It is linked to the golden ratio, a number which is of great importance in biology, such as the number of petals on a flower, the number of spirals on a pineapple, the shape of seashells, etc. This crater does not exist on the moon, but Fibonacci is important for the development. I can't believe there's not a Fibonacci crater. That's insane. That's madness. Pure madness. 3.12, let's go. Where are we doing? We're 40 minutes in, that's fine. Whoa, this is a big map. So we have 2 positions. So what I'm seeing here is are we going to keep our velocity, you know, going from a position? What I'm seeing is that we want to do is go like so this is up 3 and this is up 3, but I can't do that because minus 5, 10 over 1 second is going to be 2 at a time. So this is also impossible. What I was thinking is we teleport here and we try to get to this one, but we can't do that. And then we would teleport here and it would go the same velocity, right? But no. No. Unless it's at a much greater angle. Which it could be. Like 3, 3, 3. Okay, so this would be... Is this 15? 25, 15. 25, 15. And then we have to go to... We go 15, 5, right? So it's 5 less on the x-axis, but it's 15 less on the y-axis. So now we're going from 1 second. We go, no, wait. We need to be at 15.25, yeah? Oh, we are, yeah. 25.15, sorry. And then we go 1 second, 2 second, 3 second. At 3 seconds, we are going to change here and go 4 second, 5 second. So we actually need to teleport to... Here, we need to teleport to minus 520. Minus 520. Let's see if this works. We should be going down here. 1, 2, 3. Teleport here and go 1, 2, 3. Heyo! Very cool. Very cool. I like that we keep the velocity. An object in motion stays in motion. Roger Bacon. He is considered to be one of the pioneers of the scientific method, which is the basis of how we do science today. The method is intended to be objective. It is made of observations, experiments, reasoning, hypotheses, calculations, and refinements. He would have said, no speech can give certainty or certainty. Everything is based on experience, and true science is the science of causes. Great. He would have been the inventor of gunpowder and would have worked on the construction of a flying machine. He investigates the properties of lenses, which allow them to have a power of magnification. He discovers the foci of concave mirrors. Very cool. Let's go. Another level 5 before we get to the 6th difficulties. I'm very worried about that. Ah! Alright. Wow. Okay, so this time we have a position... Then a velocity, and we change position, and then we can change velocity again. So, position. Let's start here. I'm imagining we start here, and we need to get here to here in 3 seconds. Let's say, and then we teleport like here, and we do the same again, and then we just change it at the end or something like that, right? Let's see. Let's do that. Let's just like pick it. We're gonna start with a random theory. I just want to go for it. Let's go 30 in 25. 30, 25. So we start here, and from 30, 25, we want to get to minus 30. So we're going. That's 60. So we're going to be going minus 20. Oops, minus 20. And we're going from 25 to 5. Which we can't do in 3 seconds. That's... Oops, my bad. That's... That's 10 seconds. This isn't going to be deep in. This is going to be 10... 20, 30, yeah. We're actually gonna shoot like down here. We're gonna be here instead. If we do it at 5, then it's gonna be 5, 10, 15. It's only we're gonna hit here instead. Okay. Let's say that's wrong. What if we go here and here, here to here? What if we go crazy and go from here to here? What does that do? That is from 30 to 15, which is, you know, we can go 15 in 3 seconds. That's 45, so it divides into 15, and we go, there we go. And we go from 25 to 20, which is 45. That is also over 3 seconds, so we can do that as 15 as well. That should go straight down to here. And then at 3 seconds, we teleport here, which is minus 30. And 5. And then we have 3 seconds to go. 1, 2, 3, which is just straight minus 10y. Let's see. And boom. And boom. Lovely. Lovely. We just went for it. First you jump in. We make some theories. Why that one up there? It's just the furthest away one. Let's see what we can do with this big grid. When you've got a bigger grid like that, you've got more space. You can have these different, there's more potential like angles that we can have. Instead of having to just do, -5 and 5 and going directly at a normal angle, 45-degree angle. Here is William of Ockham. He promotes the principle of parsimony, i.e. the principle according to which one must always seek the simplest cause for a phenomenon. This creator does not exist on the moon. The principle of parsimony has been very important. Could not help adding him. Okay, so we've got 3 more, and these are 6 ones now. We're gonna do these last 3 if it doesn't take us too long. Oh, we got 2 graphs, baby! Did you know? In order to free yourself from the gravitational pull of the Earth, your car has to reach a speed of more than 40,000 kilometers an hour. This is about the speed at which you would have crashed into the ground of the moon if I haven't slowed down your run. Space torture, okay, your service. Wink, wink. Okay, so what we have here is a position, a velocity, and a displacement. So we need the same angle. We're going to be moving in one direction, basically. And then we get teleported and we're going to continue moving in that same direction. With the same velocity. It's same direction. With the same velocity. Which implies a direction as well. So we need... Okay. This is a weird one. Because immediately I'm thinking we go like... You know what I mean? Like you go bang, bang. But then it's 1, 2, 3. Actually, it does work. It does work, yeah. So we will teleport to this one, which is -30 plus 20. And then we're going to go, it's going to be 5 and 10. So plus 10 minus 5. So we're going 1, 2. After 2 seconds, we are going to displace from here to here, and then it's going to be 1, 2, 3, 4 more seconds to reach here. You see, we're going, across 2 squares and down 1, basically, with the speed. This velocity. God, I keep saying speed. 2 seconds. So we're going to be here. We're going to be at -10, and we want to be at -30. So we're going to displace -20. We're going to be at +10, and we want to be at -10. So we're going to do -20. Let's test our theory. 3 and 4. Look at that. All right. Crushing it. Doing really well. This game's cool as heck. This game's super cool, man. This game's super cool. Here's Jean Buridan. He says that when an object is set in motion by a force, it continues to move because of its momentum, its impulse, called impetus. It proves that the deceleration of an object is not due to a loss of momentum, but rather the application of a force opposite to the movement. The creator does not exist on the moon. Well, he is also very important because it's also entirely correct. What a great theory. So far. When you say correct, what you really mean is we believe that to be true. With our current knowledge of mathematics. So, we actually have a 1, a 2, a 3, and a 4 different ways to change velocity now. So we can actually go teleport and then 1, 2, 3, and I don't know what the 4th one's for. Maybe we have to change it twice. We'll see. But let's teleport down here first. We actually need to go 1, 2, 3, 4. 1, 2, 3. But we need to teleport here. So we will teleport. Oh, we can't. We're starting here. So we actually need to go 1, 2, 3, 4, which is all 4 of them. So we need to go -25, -30. -25, -30. Well, we can do that in 1 second. We can't do that in 2 seconds. So we're going to do that in 1 second. It's going to be very fast. We go -30. We go -25. That's 1 second down. Then at 1 second, we are going to go. We need to go from -30 to 15, which is 45. So we're going to go 15. That's going to be +15. Because we're going to do it in 3 seconds. So we get here when this 4 seconds is up. And we need to go from minus 25 to 20. So that's again 45. So it's another 15. And then once we reach here, we need to change direction to this one over 2 seconds. So we want to go here and here. So it's 15 and 5 again. So it's minus 15 and minus 5. That is at 4 seconds. And then at 6 seconds, we are going to change from minus 15 to positive 25, which is 40. Ooh. We only have 2 seconds to do that, so that's 20. And then we're also going to go from positive 10 to minus 30, which is 50, so we can do 25. Let's test our theory out. Let's go. Let's test it. Whoa! That's some velocity on that, some speed. Ah! Did it the wrong way! Whoops! I didn't go negative. What a fool. Look at that. We didn't go negative. 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 Just shot us off into the side of the crater. 1 and 2. Sweet. Alright. Doing very well. Silly little mistake at the end there, but you know, it's going to get us every now and then. Nicole Oresm. He publishes the Merton's theorem, or mean speed theorem, which was stated by the Oxford calculators. This theorem, which is only true if the acceleration of an object is constant, lays the foundation for the mathematical description of motion in mechanical physics. He is the first to represent a mathematical function graphically. This shows how the velocity of an object having constant acceleration varies over time. Without being able to prove it, he believes that the Earth turns on itself. Without being able to prove it. People are insanely smart. Let's look at these. Some extra rovers have appeared here. What's this one? November 18, 1969. Apollo 12 became the second spacecraft to make a success crewed lunar landing. Only, what's that? Only like 5 months later? 4 months later? Crazy. Before leaving the moon, the astronauts left several devices on its surface. These tools autonomously harvested data on the ground's movement, magnetic fields, solar winds, etc., then transmitted them to Earth. And you? On April 17, 1967, Surveyor 3 became the second US spacecraft to land successfully on the moon. Surveyor 3 had a device for digging trenches on the surface of the moon and a sampler to analyze it. Based on the data collected, scientists concluded that the moon's surface has about the consistency of wet sand. The consistency of wet sand, which is enough to support heavy spacecrafts. November 18, 1969, the Apollo 12, which we just read about, landed within 200 meters of Surveyor 3. The next day, the astronauts walked to Surveyor 3 to collect the pieces of the spacecraft and analyze the effects of more than 2 years on the moon's surface. Very cool. On June the 2nd, 1966, Surveyor 1 became the first US spacecraft to make a soft landing on the moon, about 4 months after the Soviet Union's Luna 9 spacecraft. It is thanks to its retro rocket and its 3 thrusters that the spacecraft managed to get from a speed of 10,000 kilometers an hour to 5 kilometers an hour during its landing. Oh, wow, that's insane. In 30 days, Surveyor 1 transmitted over 11,000 photos of the moon, in addition to providing data about the moon's surface and its temperature. Okay, last one in this area before we go back and get the one that tricked us. Get the one that actually stumped us. Oh, so these drones are moving up and down. We have 3 velocity changes and an initial position. So I'm seeing we teleport here and then go 1, 2, 3 or something like that. Or 1, 2, 3. What do you think? Let's start here. Let's actually start here then. Minus 20. You know what? Wait a second. Yeah, they never actually go to the batteries. They never actually go there. So I'm wondering if we can just kind of sneak around them. Let's just once again throw something out there. See what we've got. We don't need to do this. This is 0. We're going to plus 25. And then velocity is going to take us out 1, 2, 3. We're going to come in here. Because then we're going to go 1, 2, 3. And then we're going to come down from 30. From 30 to 0, which is 15, and from -5 to -35, which is also 15. Okay, so this should be... We have 8 seconds, so that would be... Click this, and then we go 1, 2, 3, and then 1, 2, 3. That's 6 seconds. 7 seconds. No. So we want to go 1, 2, 3, and then 1, 2, 3. That's 6 seconds, and then we're gonna go down here in 2 seconds. That's how I'm gonna try and do it. So 0, 25, yes, and then 1, 2, 3. 1, 2, 3. We're gonna be 30, 25. So we just need to go in 3 seconds. We just need to go positive 10 to go 3 seconds. Okay, and then we need to go here. We need to, it's across. Where is it? It's across here. Is it 1, 2, 3? Yeah. So 1, 2, 3. We want to go from 30 to... What am I doing? Oh. What am I doing? It's going from 30 to 10. So we want -20 in a second. And -5. So -20, -5. And that's going to be... So that's going to be 1, 2, 3 seconds. So there we go. And then it's going to go... We're going to do that also for 3 seconds. And at 6 seconds, we should be here. And then we want plus 15 and -15. Let's see how this works out. Should go here, 2, 3, and then we're gonna go bang. Oh, we missed it. Oops. What did I do wrong there? Can I see that again? We go 1, 2, 3. We're at -30, and we need to go across here. Okay, so this is... We need to go from -30 to 30 to 10, which is -20, which we did correctly. Oh, but we only did it -5. That was silly. Okay, we need to do -10. 1, 2, 3 seconds. 1, 2, 3 seconds. 1, 2 seconds. All right, good. A little silly mistake there on the y-axis, but okay. We've done it. We're done. We're done. This is only crater 3. Look how many batteries we have. I thought we were doing okay. I've got to look at crater 4. Crater 4 looks tiny. Oh, jeez. 5. 6 looks okay. 7. Oh, my God. Okay. Crazy. Let's go back to 3. One more set of batteries to get here. I don't know which levels we've completed all of the batteries on. It would be nice if it maybe showed us here which ones, like, highlight it in gold or something, like you've completed this one 100%. That would be really nice for us. It doesn't really do that. So we don't know where we need the batteries. So we do need to make sure we do get them all on each stage. Maybe you can't pass the stage until you get all the batteries. So this one that stumped us. So we need to survive. We can go -5. That's 1 second. Then at 1 second, we go +5. We go 2 seconds, 3 seconds. And then that's all. We're dead. But we have to start in the middle. And we only have one... We're in 0, 0, and we only have one direction we can go, basically. It can be here in any direction, but it's still only one space, which is 1 second. It's still only 1 second. So what if we go here? And then we go, after 1 second, we go... And then this is going to go to the battery. Watch. Put in 1 more second. We've still got 3 seconds to do. How do we survive for 3 more seconds? How do we survive for 3 more seconds? I feel like we're missing an extra jump. Like we need something else. There's no way. Oh, this is only at 5 seconds does this do anything. Only at 3 seconds does this do anything. This is killing me. Killing me. I feel like we have to... we can't move. I feel like we have to stand still. Either there's a problem with this mission or my brain is broken. Because this one has completely stumped me. We can't control anything here. We have an initial velocity which we don't want to use because we need to survive the entire time. And this we want to take as long as possible. And then it just goes forward and we die. We wait. And then we hit the wall. Just before. It's crazy. It's crazy to me. I don't understand it. There's a hint. I'm very tempted to take this hint because I think the hint's going to teach us something that maybe I don't even know about the game. I'm very confused by this. I'm very confused by this. So let's say it's everything's per second. So we can only move 1 square a second. Which means if we move anywhere, this has to be set to 1. And then we somehow need to survive for 4 more seconds. It won't happen. I'm gonna look. What do you think is the velocity of a vehicle that is not moving? No, okay. So it's telling us to do that, not move. That's what I believe as well. That's what I already did. But setting this to 3. And this to 5. I kind of need to go to -5 and then come back. If we could set the initial position here, it'd be okay. But we can't. I'm so confused. Initial velocity, nothing. At 3 seconds, we go here and we kill ourselves. Like, I understand we could just not do anything and, like, survive the level, but we don't get the battery. Does that count as a win? We survived? Okay. I feel like we need to change this initial position to be back here. Max 3. One, two, three. Everything is everything. I use the hint and it's still, what do you think is the velocity of a vehicle? It's not moving. I know that. I know this has to be 0. But then this doesn't make sense. I'm blocked at 3 seconds. Everything I do takes 1 second. Everything I do takes a second. And I have to survive for 2 of them. Because I can't make this any later. Which means I have between 3 and 5 seconds to do something. And to get that battery takes 1 second. And then the second later I'm in the wall. I think this level might be broken. I don't know. I think this level might not be possible. I do. I think this level is there's something wrong with it, or I'm just completely not seeing the obvious at all. Like, we can't alter the initial position. This velocity, if we do anything with it, just means we have to survive even longer, which is beyond reasonable. No! Can we stop the car moving after already moving? You can stop the car after it started moving. What am I doing? Of course you can. What an idiot. What an absolute idiot. That took so long to solve. I've just had it in my head that you keep moving. But of course you can set it back to 0 afterwards. Not seeing the obvious at all. Set it back to 0 after you've already moved to the battery. I'm an idiot. Okay, well, we did level 3. That is incredibly embarrassing. I hope you didn't see that, Mr. LaFlamme. That was incredibly embarrassing. But that's the end of that one. That's another hour down. That's worlds 1 and 2, then world 3. World 4 will be, hopefully, I mean, looks like an easy one. And then, so maybe we'll do 4 and a bit of 5. And then we'll do another one on 5, and then 6 and 7 might be the video all of their own, because they're going to get a little bit crazy. This might be 2 videos. I'm having such a good time. I want to play some more, but it's so warm in here. That space tow truck, if you like the look of it, I mean, obviously I want you to keep watching my videos, but if you like the look of it, once you know the answers, you know the answers. So maybe you want to go check it out for yourself. It's on Steam right now. It's very cheap. And if you want to see my full review of it, it should be below, actually, by now. And I have also a bunch of links below that I've noted down here I'm going to add for a bunch of edutainment channels on YouTube if you like this kind of stuff. Thanks for watching, and I'll see you next time.